Welcome to this explainer. Today, we are stepping straight into what is essentially a thrilling, high-stakes cosmic detective story. For decades, we really thought we had the fundamental rules of the cosmos pretty well figured out. We had our models, we had our math, everything made sense. But recently, the universe has become a bit of a crime scene. 3 massive, completely baffling anomalies have appeared in our data. 3 distinct clues that are quite literally breaking the laws of physics as we know them.
So it brings up this terrifying but frankly fascinating question. What if everything we know about the universe is just wrong? Because suddenly our most exact state-of-the-art measurements of the cosmos are turning up flat-out incorrect. And we aren't just talking about some minor rounding error here. This is causing a full-blown crisis in the world of physics right now. It's forcing the brightest minds on the planet to fundamentally rethink the very fabric of reality.
To really set up our mystery, get this, a Nobel Prize winner recently went on record stating that there is possibly something outside our universe causing all our measurements to be wrong. Just think about the sheer magnitude of that statement. Our universe is a crime scene, and the culprit might not even reside within our own dimensions. So to track down this culprit, we need to carefully examine the 3 distinct clues that our current laws of physics simply can't explain.
Okay, let's dive right into this. Clue number 1, the expansion mismatch.
To understand this one, we have to look at the Hubble constant. Basically, this is the number that tells us exactly how fast the universe is expanding at this very moment. Measuring this should give us a single, universally agreed-upon speed limit for cosmic expansion, right? But, as we are about to see, the universe is absolutely not cooperating. Here's the tension in the data. One team went deep, measuring the cosmic microwave background, literally the oldest light in the universe, and they calculated the expansion rate at 67. But then, another team measured it directly, using pulsating stars and exploding supernovas, and they got 73. Now, naturally, scientists just assumed one team made a mistake. But when they used the new, highly advanced James Webb Space Telescope to check their work, the numbers were perfectly correct. Both of them. Neither of these wildly different measurements is a glitch or an error.
Now, you might be thinking, okay, 67 versus 73, that doesn't sound like a big deal. But structurally, it is a massive contradiction. To put it into an everyday perspective, it's like waiting 2 minutes versus 3 minutes for your microwave food. It is an excruciatingly different amount of time when you're the one waiting. In cosmic terms, these 2 numbers dictate completely different sizes, ages, and scales for the universe. It literally means the universe is acting completely differently depending on how we look at it.
All right, let's move on to our next piece of evidence. Clue number 2, the impossible galaxies.
When astronomers use that exact same data from the James Webb Telescope to look way back, to just 500 to 700 million years after the Big Bang, they found these massive galaxies. They were already the size of our own Milky Way, fully formed, just sitting there in the infant universe. And simply put, they should not exist. To understand why this is such a huge problem, keep this number in mind, 10%. Everything we know about astrophysics dictates that early galaxies should form at about a 10% efficiency rate. Why? Well, because the early universe was a totally chaotic mess. Most of the hot gas just drifts away, gets blown out by solar winds, or is simply too energetic to settle down and condense into stars. 10% is the expected speed limit for building a galaxy.
But these early impossible galaxies we found, they are operating at a mind-bending 100% efficiency. 100%! Every single scrap of gas is seemingly turning into stars instantly. It completely shatters our current models of how matter is supposed to behave under gravity over time.
It's operating like a manufacturing factory with absolutely zero waste. It's totally unnatural. Now, at first, scientists thought, okay, maybe we're just seeing incredibly bright black holes that happen to look like massive galaxies from a distance. But no, even after researchers went in and manually removed every single bright black hole from the data, there's still way too many massive, highly active galaxies. The zero-waste factory problem absolutely remains.
And this brilliantly illustrates our third and final anomaly. Clue number 3, the missing clumps.
Matter in the universe simply isn't behaving the way our standard models of physics say it should. When we zoom out and look at the large-scale structure of the cosmos, we fully expect to see matter clustered together in very specific, mathematically predictable ways. Scientists expect it to be highly clumpy and structured, galaxies and dark matter tangling together in these dense, beautiful cosmic webs. But whenever they actually measure it, the universe is unnaturally smooth and unstructured. There is far less clumping than predicted. The overall structure of reality is, quite literally, too even.
To put it simply, it's like buying a textured, chunky tub of grocery store ice cream and then leaving it in your car where it melts into this perfectly smooth, featureless puddle. It loses all of its expected structure and just flattens out in a way that totally defies our standard models. So let's recap. We have an expansion mismatch, we have impossible hyper-efficient galaxies, and we have an unnaturally smooth universe. What in the world could possibly cause all three of these things?
Which brings us to the grand reveal, the multiverse solution.
When scientists finally took all three of these physics-breaking clues and plugged them into incredibly advanced mathematical simulations, they found one mind-blowing theoretical solution that answers all of them perfectly. The culprit isn't inside our universe at all, it's outside of it. To really grasp this, we have to completely redefine reality for a second. Imagine our universe is not just an infinite empty box. Instead, it's a brane, short for membrane. It's this three-dimensional surface containing literally everything we know: our galaxies, our light, our fundamental forces. And this brane floats inside a much, much larger structure called the bulk, which is the 11th dimension. Light and electromagnetic forces, they are stuck on our brane. The only thing that can actually leak out of our universe and into the bulk is gravity, via these theoretical particles called gravitons.
Now, what's really wild here is the geometry of it all. Inside our universe, we have what's called de Sitter space. It has positive curvature, meaning everything is expanding outward. But out there, inside the bulk, it's anti-de Sitter space. It has negative curvature, meaning space violently compresses and folds inward on itself the further you go. And because of this extreme folding, other universes, other branes that seem billions of light years away mathematically might actually be hovering mere micrometers right on top of us.
Normally, there is this unseen bulk field of energy that keeps all these different universes from hitting each other. It repels them, kind of like two gigantic cosmic magnets. But the bulk field isn't perfect. If it happens to fail to repel, two branes can slowly drift close together. And when they do, they make physical contact, sort of like gently setting a dinner plate down on a flat table, allowing raw energy to transfer directly from one universe right into another.
And here's the crazy part. We actually have incredible observational evidence that our universe has been physically grazed by another universe. Back in 2008, NASA discovered something called dark flow. This is over 1,000 entire galaxy clusters moving in the exact same direction across 2.5 billion light years, seemingly being pulled by something outside our observable reality. We also have this massive cold spot in the cosmic microwave background that is 1.8 billion light years wide. In bulk physics, these aren't data errors, they are scars. They are the exact impact marks of another universe grazing ours, dumping massive amounts of energy that permanently warped our expansion rates and supercharged our early galaxy formation. Let's see how this builds into even more extreme scenarios. A graze leaves scars, sure, but what about a merge? That's when a lower energy universe fully absorbs a higher energy one. The physics of the incoming brane literally overlap and supercharge the host. In fact, multiverse interaction models suggest that our very own Big Bang was just a merge event. Just another brane dumping immense, unimaginable energy into ours. And if they collide head-on, oh man, it's a total kinetic reset. Both universes shatter like two Lego models smashed together, completely resetting into the raw base energy of a brand new Big Bang.
If a merge or a fundamental swap were to happen to us right now, you wouldn't even hear an explosion. Two universe-sized membranes would connect, instantly converting all that impact energy into violent heat. The very first sign for you would simply be a literal wall of different physics moving at you at the speed of light. Universal constants like gravity or the speed of light itself would change instantly. Once that boundary hit Earth, our specific arrangement of matter would just stop being valid. You wouldn't burn up, you would just instantly cease to be.
So the absolutely crucial point here, the big takeaway, is how beautifully this unified 11th-dimensional theory ties our cosmic crime scene together. The Hubble mismatch? It isn't a measurement error, it's a structural disruption from a bulk raise. Those impossible 100% efficiency early galaxies, they were literally supercharged by a massive dump of energy from another brane. And the unnaturally smooth, missing clumps of matter? Those are the lingering interaction scars left behind from where our universe literally rubbed up against a cosmic neighbor.
Which leaves us with this final, thrilling, and maybe slightly terrifying thought. If the 11th-dimensional bulk mathematically resolves our current physics crisis, and if our own Big Bang was actually just a collision between two floating universes, what else is out there right now drifting invisibly, just a micrometer away from you? Thank you so much for joining me on this explainer. Keep wondering, keep questioning, and I'll see you in the next one.